Hello everyone, welcome to NHSRAG, the addressing multi-hop medical QA with name entity heuristic search RAG. So for the first, for the research gap that we try to identify the research questions that's nowadays have high deployment costs of the dense vector RAG. Building and serving dense index is costly in the compute and storage limit accurately for frequency, and that changing source, it is like remove the index. And LM-driven query decomposition overhead prior work decompose query with LM itself. It takes a long time for the inference. And how far do small LM model compare in performance to LM company models? And the last one is trade-off between cost and accuracy when you use some small model vs large model.
Here is our proposed method. First, we do a query formulation by leveraging the pre-trained sparse model to do a pure stacking and noun chunking to effectively extract noun from the query which consider it to be the entities that are related to the question. We select top 3 entities to generate a two adjacent clause combination, aim to make a query result to be related to their relationship so we can use those data to answer the multi-hop question answering, which this clause will be mixed up with the raw entities and select only top 5 due to our resource constraint for searching and retrieval. We then use this query to search on the text-based search engine, which is in this case is the Wikipedia, and then extract the summarized section, applying one-shot prompt template, and then generate the response with the 4-bit quantized MedReason 8 billion models. Then we use a regex to extract the answer, and if the short answer is not found but the long answer exists, we will summarize the long answer and use it as a short answer. But if the response is none, we will fall back to use the Gemini 2.5 model in order to do the multi-question answering task. To clarify our query formulation method, here is an example. From the question, now clauses are extracted, then are concatenated, creating the query pool, and only top 5 of the context receiving from the search engine are used. Cool. To clarify our query formulation, here is an example. From the question, now clauses are extracted and then are concatenated, creating a query pool, and only top 5 of the context received from the search engine using the query in the query pool are used as a context for answer generation.
For the experiment setup and baseline, we try to inference the data and add 10,000 of the questions and have 1,000 hidden questions from the MedHopQA challenge. And metrics that they use is exact match on the short answer. And we try to use compute with full 880 gigabyte due to the we want to have less time computation, and it's performed the score on the NHSRAG by use MedReason models with 4-bit quantization with the pipeline of NHSRAG. It's performed the score at exact match in around 0.43, and the questions that we try to prompt to prevent to answer the the question that not have the does not have sufficient information from retrieve to use the fallback with Gemini, and is performed in this rack plus fallback from Gemini to be 0.75 exact match score, and the Gemini 2.5 Pro is performed the greatest around 0.73, and the MedGemma for the detail prompt is performed a 0.55 score. And for the NHSRAG is performed well in Save the Course to be around $267. Next. Yeah, well, for the cost comparison, for the Gemini's fallback system is perform the course around 313 with 1,000 questions at that are fallback, and it's performed reduction of 77 percentage less than the MedGemma zero shot approach, and about 48.5% price of the Gemini API approach is a financially viable option for academic research in medical domain like a multi-hop QA. And for the discussion, NHRAG with medicines XB quantized probit effectively match the performance of MedGemma 27B with a simple prompt. Next one. Okay, for the performance comparison that we already tell you that the greatest is Gemini 2.5 Pro, and the NHRAG achieved this. The nearly score the MedGemma 27B with the full model and detailed prompt, and is equal to the MedGemma 27B with a simple prompt. For the discussion and future direction, we will do the large proprietary models such as Gemini to excel with the integration of search and or use the Wikipedia search, and try to modify the new prompt for Gemini's APIs, and our XB rack pipeline match 27B zero shot performance at lower cost, and retrieval quality is the main bottleneck. Abstention prevent the hallucination, and for the hybrid fallbacks, balance cost and accuracy to reaching 0.75 exact match score, and we will try to improve retrieval via domain-specific ranking and research source, and try to export lightweight model with better reasoning capability, and investigate ensemble or adaptive hybrid strategy for complex query in the future. Thank you.